What is up, my friends? My beautiful, amazing friends. Today, we're doing an interesting thing. So if you remember last video, I said we're gonna use LiDAR drones and shit to go to the Netherworld border. I had an epiphany, right? A bit of a brain blast. A bit of a genius idea, you could say. You could say that. You could say that if you wanted to. I mean, it would be true, but it is a brain blast. So, I thought, you know, what if I didn't do that? What if I instead put all my effort into perfectly recreating the Nether, the ultimate training ground? If I have a procedural generator, or sorry, procedural generator for the Nether. If I made my own procedural generator, theoretically, I could perfectly recreate the Nether. All of Minecraft is right here. Like, I have all the code here. It's been de-suffocated. Theoretically, I could go through here, figure out what makes the Nether tick, copy it all into a Rust script, and build a one-to-one replica of the Nether. I started thinking about why this wouldn't work, but then I realized that my other option, using LiDAR drones, was just as ridiculous. Like, it would be just as insane. But this, if it works, like, this would work. Like, this would actually work. Like, if I managed to make this, it would work. Like, if I managed to make a one-to-one replica of the Nether, I would exactly get there. So that's the plan. That's what we're gonna do. So, I've done a little bit of work. I've worked on trying to figure out how the biomes work. That's my first responsibility. So, how they work is each biome has 7 different parameters: the temperature, the humidity, the continentalness, the erosion, the depth, the weirdness, and the offset. All the biomes have these different values. What happens is all these pieces of data are treated as if they are a dimension in a coordinate plane. And because there are 7 different pieces of data, there are 7 dimensions. The game refers to this 7th dimensional stuff as a 7th dimensional hypercube. That's how the game refers to it. This is written wrong. It's not 6 dimensions, it's 7 dimensions. And so what happens is it gets the Euclidean distance just like you would with a point. If you had, for example, if you had a vector like this, then the way to get the Euclidean distance, because this is like a right triangle, you can draw a line here, and you can draw a line here, and then if you did this line's distance squared plus this line's distance squared, you'd get this line's distance squared. That's the Pythagorean theorem. And what happens is Minecraft is just taking that exact same concept and doing it here, extending it into 7 dimensions, because it doesn't have to be 2 dimensions or 3 dimensions. It could be 4 dimensional, 5 dimensional, 7 dimensional. So it takes the 7th dimensional Euclidean distance squared, and what it does of a point based off a random distribution, and what it determines is the point that it's closest to. It calculates the distance by checking how far outside of the bounds for the parameter it is. And then what it eventually decides is whichever one it's closest to, whichever biome's parameters it has the lowest Euclidean distance to, is the biome selected for that point. So that's how it calculates the biome. Now, we're actually pretty close to being finished with the biome conceptually. There's only one thing remaining. We don't actually know what point is. We see point, this value, noise value point, its noise is being used for the comparison. But we don't actually know how it's calculating the noise, what math it's using to calculate the noise. We need to figure out where's the noise coming from. So, first question, is this .temp, what is this? This is a hypercube. And when this noise hypercube is created here, it's created with fixed values. So we know that, where is it? So we know, where did I lost myself? Where was I? Yeah, here. We know point contains the noise. This contains the fixed biome values. So the noise, we need to find it in this point variable. What is this? So it's a type noise value point. Okay, so where is get square distance called? It is only called here. M equals math.min m noise dot get square distance noise value point 2. Okay, let's take a look. What is this? Multi-noise that fitness position finder. Calculate fitness. Okay, and it takes in a list of noises. It takes in a list of hypercubes. And it takes in a list of hypercubes. So noises is hypercubes. And a noise sampler. It takes in some samplers. I'm not exactly sure. Sampler. I'm not exactly sure what that is. But I did not. Maybe we'll find out what that is. An int x and z. Likely coordinates. I'm guessing two-dimensional coordinates. It could be. Math helper dot square. 2500. Right, and this just takes. Yeah, it's just this. It's just a square. So why 2500? 2500 squared is 625,000. Why that specifically? Int I equals 2. What do these values represent? Int L, or long L, equals math helper dot square 10,000 times math.pow math helper dot square long x plus math helper dot square long z, and we divide those by d. We set to 2. So this appears to just be some sort of magic noise equation. So I marked this as not important, but I don't believe it is. I believe this is important. Okay, and we set a noise value point. Not exactly sure what that is. We need to create a list of things that we need to determine what they are. Let's use Vim. I'm not very good with Vim, so I guess we'll create a Vim file just so I can try it. So let's see. Let's go to the cds run media grand sugar auxiliary m.2 dev Nether generator, and we'll make a new file called theories. So we need to figure out what is unknown. We need to figure out what is multi-noise util.noise value point. I'm not quite sure what that is. How do I do this? It's semicolon exit semicolon w. Yeah. So we don't know what that is. I have no idea what that's supposed to represent. Then we do a second one. So this is likely some sort of point. Sampler.sample block chords. Biome chords dot from block. I don't know what that means. What is biome chords dot from? Oh, hold on. Yeah, I'm not exactly sure what biome chords dot from block is. Oops. Y level, so we don't care about the Y level. So Y is insignificant. That makes sense. Minecraft only uses the X and Z. Yeah. It only uses the X and Z, so we don't care about the Y level for these biomes. And so it calculates noise by sampling, and then it gets the noise. So the next thing we should be looking at is probably noise value point. That looks important. Depth, we don't care. So maybe that's for caves, and we just don't care. And weirdness noise. And then we get m long dot max value. Okay, so we get the maximum highest value. Multi-dimensional noise, dot noise hypercube noises. Oh yeah, I'm not familiar with Java. What is this saying? I'm gonna ask the big GPT. Sorry, I don't really have experience in Java. Iterate over every element in noises, and for each one, call it noise hypercube. Okay. It's okay, so it's the Java thing. I've never seen a for loop like this before. So in noises, so for each hypercube, so for each hypercube, we are setting m, which is a long value, to math.min get square distance. Okay, so we're finding the closest hypercube to noise value 0.2. So what this is doing is, you can see here, it has a really huge value, and then every time it goes through, and if the value is lower than m, it gets set there. So we're trying to find the closest value. All right, and then we are returning new block pos xj. The fitness is equal to L plus M. And so L, not exactly sure what fitness represents here. So fitness, not exactly sure. Fitness in like traditional algorithms means like how likely it is to move on to the next iteration. So well, we need to put fitness. What is that? What is fitness? Okay. Yeah. Gonna get a second opinion from a large language model here. Alright, I'm gonna go to the bathroom. Ah. Why does no one ever watch my streams? Alright. Put on some bye bye that you can hear bye bye there. Right? But I want to listen to it too. So let's go. You know, let's go ahead and put it on. I'm gonna put it on myself, then I'll switch to desktop audio. I want this in my ear. I need it to focus. Bye bye there. Oh! Fuck! That scared the shit out of me. Oh my god. Hey! Get a load of this guy. Get a load of this guy. Alright, let's go. I'll go ahead and mute the main audio. No, I'll go ahead and just stop audio. Okay. Loop. Clear toggle between loop. Loop it. Look how fat my chin is. Okay, so L here. This valley gets larger as distance from the XZ coordinates passed in to calculate fitness are passed in. This function is calculating the fitness of something. So the higher L is, the farther it is, the farther what is. From what? So just the larger the values are. Not explicitly from anything. So maybe it is, but I don't know yet. Okay, next we gotta figure out what exactly is sampler. I need to get to work. I need to get a job. There it is. There it is. Pause. What? That is disgusting. That is disgusting. Wow. Holy. That is disgusting as hell. Okay. Okay. We found it. This is the magic sauce. We've traced it all the way back. Density function dot unblended noise position. It takes in an x coordinate, a y coordinate, and a z coordinate. Converts does biome coordinate to block. We still don't know what this does. And then it does it uses a density function to get the unblended noise position. Inside of here likely contains that data. The unblended noise position. Oh, whoops, I didn't mean to do that yet. Where was I? Oh, why am I here now? We want to go to the sampler. Yeah. Yeah, no, I want to go here. Yeah, okay, so the density, unblended noise. This likely does some sort of Perlin noise. Or maybe simplex noise or something. We'll look at that in a second. I'm interested in this right now. Multi-noise.create noise value point. So we actually need to remove this comment. I'm gonna call this a multi-noise. I'm doing this just so I can grep it later. Grep, I'm so cool. I'm so cool for saying grep. Like I'm like such an OG grepper, you know, from the old and hold on. Yeah, sometimes Hyperland acts up with screenshots. It's like a 1 in like 30 chance it doesn't work. Okay, multi-noise util. We're gonna move parameter range. I'm gonna get rid of you and put you over here. By the way, if you like, there's this guy who made a compiler, and that's where I found out you could use this like app to like model things, and I've been using it. It's so nice. I'll put you here. Let's do this. Okay, create a copy of it. Whoa, no. Next, I'm gonna make this bigger because it is pretty important. The sampler is what we have, and it points to the density function, which I'm not exactly sure what that is, but I have a feeling we're getting closer to the actual noise, which is really what we're concerned about right now, is being able to calculate the noise. And this is going to be multi-noise sampler. This is really what we care about, mainly the sample function. So we're gonna return this. I think I was originally wrong about what this did. I thought it just returned samples for a block coordinate, but I think it does much more than that. I think it's actually responsible for calculating this stuff. So yeah, we can see here the density function. Okay, so like let me just go over it. What I think is happening. We've taken an x, a y, and a z value. These are likely world coordinates for some sort of block. We then do biome coords.to biome co. Oh my god. Okay, holy brainwave. You remember how I just said that these values, the value. Oh my god. Oh my god. Oh my god. Where was it? Where is it? God, why is this so hard to find? Come on, I'm having such a brainwave. I need to find it. Here. Remember how I said are x and z relative to the world? This function suggests otherwise. Biome coords. It's probably converting them into some sort of coordinate frame relative to the center of a biome. So how would it know where the center of a biome is? Biome coords could give us another lead to where that is. But that brings up another question. If it's converting to biome coords when it's sampling, then it must already know where a biome is. 2 block. Okay, we'll worry about that in a second. So density function to unblended noise position. Unblended noise position equals new density function unblended noise. It takes an I, J, and K, which are the converted values. Okay. Then it creates a new noise value point, which we've already established. A noise value point is just a container for the dimensions. And in this, it says this.temperature dot sample. So temperature is sampleable to the unblended noise position. Humidity is sampleable to the unblended noise position. Continentalness is sampleable. These are all sampling except, you'll notice, for offset. Offset seems to be some sort of fixed value. Okay. We're getting closer. So where do we want to explore next? Let's go ahead and look at the sample functions. I think that's our best bet. So let's take a look at the sample functions. So we have a sample here. This double sample, the density value for the given block position. Right. Noise chunk generator is where it's called. Density function. Okay. So temperature dot sample. What is temperature exactly? Temperature is a multi-noise sampler. No. It's a density function. It's a density function. What is a density function? Okay, so temperature is a density function. What is a density function? Represents a function that maps from a block position to a density value. It can be defined in code or in data packs by using predefined function types like a constant value. Which, okay, let's take a look. A codec registry, if we don't care, that's serialization stuff. Registry entry.new, if we don't care. Returns the density value for the given block position. Right. And then there's all these mathematical functions. Okay, we care about sample. Record noise. No, okay. Okay, we need to figure out, so the temperature calls the sample function with the unblended noise position. So it takes in, we need to figure out where is sample called, where it takes in an unblended noise position. It's got to be somewhere in the entire project. It's shift to do that, right? So there's got to be somewhere where we have a function unblended noise position, implement density function. Okay, I need to figure out block state is sampler.apply. So we're doing more sampling. I need to figure out where is the actual function that takes in this data. No, you're defining it. You're defining it. No, you're still just defining it. Where do you actually... No, that's noise pause. Is there anywhere in this entire code base? Density function unblended noise. It needs to take this value in. Is there any function that takes this in? We have a record of it. 12 usages. Show me. The N biome, multi-noise util. Okay, let's look at multi-noise util. Okay, so this is where we're looking. So the sample function it runs on a density function, right? The density function has a dot sample. So okay, I think we need to make. I need to write this down. Like what we don't know what dot sample is. This is why I don't like object-oriented programming, dude. It's super complicated to follow this stuff. So we need to figure out what sample is. Let's put this back on. Go fuck yourself. What the fuck was that guy's problem? Okay. So what is sample doing? What is Minecraft doing when it's sampling the Nether? Okay, want to play? If you ask me that one more time, I swear to God, I'm gonna kill you. So it takes in density function at noise position. Okay, where is this implemented? Beardifier. Binary operation. Blend alpha. Blend offset. None of this is really helping me. This is implemented in density function types. Lovely. Shut up. What is temperature? Temperature is a density function. It takes in dot sample is taking an unblended noise position. Okay, so it's a function of noise position. So it represents it. So sample returns the density value for the given block position. Here, I'm going to turn the music off for me and put it on the stream because I need to think. Here, it's coming back in a second. I think it's this one. Watch it just completely not be that one. I can't hear it, so I'm just really hoping it is. Yeah, it is. Okay. Okay, this is hurting my head. God, why do they have to do so much OOP in Minecraft? Okay, so sample. It's just defined. Where's implemented? But it's implemented 27 times. Why is it implemented 27 times? Why can you have 27 different implementations of the same function? I'm confused. This is confusing me. How do I know which one it's doing? What? Okay, it sends in. Okay, beardifier. Let's look at beardifier. Like beardifier. Beautify? Who cares? It implements beardifying. It samples it. Okay. Okay, so here's what I'm gathering. Wanna eat. I already ate, bro. here's what I'm gathering. The temperature interface, right. So temperature is a type of density function. Okay, so what type of density? So we need to figure out, so each of these is a different type of density function. And sample depends on what type of density function it is. This is going to be so difficult. Okay, so we need to figure out what type of density function these all are, or we have to implement all of them. Okay, because there's multiple biomes. Fuck. You see, this is why I don't do OOP anymore. Object-oriented programming causes this bullshit, okay? Because why is there 27 different... Just pass a little packet of data. A packet that says noise generation information or density function information. Density information dot temperature generator. Boom. It's so you can read it. Why do I have to sit here with my head on fire thinking about how the hell this shitty ass game does this shit? No wonder it runs like shit. Object oriented programming. Go fuck yourself. Add this to the unknown. Please stop cursing. Go fuck yourself. So density function dot sample has so. Oh my god, this is pissing me off. My head hurts. My head hurts. My head is actually hurting right now. I need to think. Okay. Okay, Minecraft. You think you're gonna get the best of me? Shitty ass game. What does temperature... Okay, who... Multi-noise sampler. 29. 29. How am I gonna figure out? Okay, there's the end biome source. What about the nether biome source? Do we have that? Because if there was a nether biome source, that would be very swell. However, I'm not proto-chunk. What's a proto-chunk? Chunk noise sampler. Noise config. Okay, there is a nether. If we go here, if we search for the nether. The nether biome creator. That sounds promising. Does this contain what type of density function they're made of? I'm gonna search this whole file for density function, and I get 0 result. So, okay, to make a biome, you have to have a density function that tells you how to make that property. Where is it? Where is the density function? Oh, I spelled function wrong. No, it's still not there. It's still not there. Why would it be there? Why would it be there? Okay, why would it be there? Nether cave carver. I don't care. Configured futures. Fortress vegetation. Forest vegetation. Fortress generator. That sounds nice later. I don't care about the portal. All I care about... Okay. We'll look at placed futures. Maybe this has a density... No, it doesn't. No, it doesn't. No, it doesn't. No, it doesn't. Okay. Density function types. That sounds beautifully exactly like what I want. Okay, what is a beardifier? Because, like, what is a beardifier? Density function beardifier. A micro world generation, the beardifier is a specific density function used by the game to generate beards, terrain adaptations around structures. It smooths and flattens the terrain around generated structures like villages and ocean monuments to prevent awkward terrain clipping. Okay, so that's actually pretty useful, but we don't care about it now. So I'm going to add that to the known. So we do know about some density function stuff. So density function is going to be potentially the most complicated thing in this whole project because there's just so much. I just deleted the whole goddamn line. This is good. This is. Shut up. Okay, density function known. Density function. Beardifier. Beardifier smooths terrain near structures. We don't care right now. Right? This is not important right now. We care about just the biomes. That's only what I care about right now. Weird scaled sampler. So these are all the different types. Creates a new density function based on code, but with a different range. Return. Okay. Linear interpolation. Sure. Beardifier. Don't care. I don't care about the beardifier. Binary operation. Okay. Okay. Easiest way to figure this out is just see. If we go back here. What uses multi-noise sampler? So a bunch of different things use it. It's called a lot of times. We even use it. So we take in create empty multi-noise sampler density function types .0. All right, what does this do? It returns density function types .constant .0. Okay, that's fine. List of. God only knows what that does. List of nothing. Did I ever mention I hate Java? Did I ever mention that I hate Java? I think I should have said that, because I don't like this shitty ass programming language. You see, I'm looking at this and I'm just dreaming of being able to write in God's language of Rust. But now, no, I have to cope with this bullshit. Java. Object oriented my ass. I don't care about your bytecode JVM bullshit. Just just tell me what's going on. Please Rust. I love Rust. I want to write in Rust so bad, but I can't. This is what happens. Like I'm trying to literally I'm trying to recreate the entirety of the Nether. I'm trying to completely copy the terrain generator. I'm trying to copy the entire terrain generator and program it into Rust. But to program it into Rust, I first must understand how it works in Java. And Java is the worst programming language of all time. Ben, you probably like Java, you fucking loser. I love Java. Shut up. Java, I hate the word. Java, JavaScript, so many bad things with Java in them. Even coffee makes me sick. I hate Java. You know, like, JavaScript is worse than Java. Oh wow, okay. I actually don't know. It's like comparing the two worst things of all time. Java is bad. JavaScript is bad. I actually can't tell you. I think I would prefer JavaScript over Java. Because I hate Java. No one likes Java. I fucking hate Java. No, I prefer TypeScript over both, but that's not an option. Okay, I'd probably prefer Java because Java at least has explicit typing. JavaScript is dynamically typed, which is evil. I hate Java. Ben, do you like Java? Do you like Java, Ben? Are you one of those losers who likes Java? I'm gonna sit here patiently for you to respond. No. Thank you. That's the right answer. That is the right answer. We don't like Java. No one likes Java. Java this, Java that. No one likes Java. We like Rust. Rust isn't Java, so it's better by default. It doesn't even need to be anything good. It's just not Java, so by default it's better. I hate Java. I'm gonna rip my skin off, dude. Okay. I need to stretch. I don't like Java. Java makes me angry. Rationally, perhaps. Java was built a very long time ago. In the day and age before modern computing, it was built with the JVM with bytecode so that any computer could run it. However, it was created during the craze of object-oriented programming. Object-oriented programming, particularly the worst paradigm ever. The performance is horrible. Organization is abominable. You can't follow the logic and tell what the computer is doing. This is why we do not like Java. There is too many interfaces in abstract classes. Organization becomes impossible. No one likes Java. And no one hates Java more than me. Alright, I'm back. Oh, that was Evil Oliver, that wasn't me. I'm sorry. Okay. What was I doing? I completely forgot what I was doing. Okay. Okay, so multi-noise sampler. We define it here. Sample, okay, so we need to figure out who's calling it. So one of these is the Nether. Do we just like look through them programmatically and see which one contains it? Get biomes in area from a sampler. Not really concerned about that right now. Locate biome, no. I'm looking for where it's instantiated. We created a noise sampler. No, it takes in a noise sampler. Where is a noise sampler instantiated? No, you're still just passing it in. It's got to be instantiated at some point. Create multi-noise sampler. That sounds like what we're looking for. This get actual density function. So we're getting the actual density function. I don't like how it's prefixed with actual. What does that mean? Is there a fake density function? Returns the actual density function for a given density. Returns the density function for a density function. What does? I'm gonna kill myself. What does that mean? I don't know how much longer I can do this for. I'm growing a hatred for Microsoft. This is making me very angry. So, okay. Why is there a fake density function? I don't understand. We take in a density function and get an actual density function. But why isn't it real? Why is it fake? Why do we... What is the point of having a function that isn't real? I don't understand. Okay. Why does it say I have 2 concurrent viewers? Who are you? Who's the other person here? Identify yourself. Who the hell are you? Tell me who you are. I'm waiting. Tell me who you are, the person. We're not gonna do this. You're not gonna tell me who you are. I know you're here. I can see you. I can feel you here. Who are you? Okay. Where was I? Noise config does define a new multi-noise sampler. Here we return a new multi-noise sampler. Here we return a new multi-noise sampler. So we're gonna look here in noise config. This dot multi-noise sampler equals new multi-noise sampler. This dot noise router dot temperature dot apply density function visitor. Density function dot density function visitor equals new density function visitor. Private final map density function unwrap equals new hash map. Private density function unwrap. Density function at instance of registry entry holder. Density function. This to unwrap computer 5%. What is noise router? Chunk generator settings at noise router. What is dot apply? Applies the visitor to every child density function. What is density function visitor? Density function. Apply density function. Default density function at noise. Apply density function noise. This is gibberish to me. What is this saying? I hate Java so much. I don't even care that I'm feeding all this to ChatGPT. I don't even care. I will kill you. Okay. Density function visitor. Density function. Under map. Density function. If density function is an instance of and registry entry holder, return that. If it is not, return instance of wrapping and wrapping, or return the density function. This appears to be some sort of serialization technique that we do not need to concern ourselves with. Apply density function. Return this to unwrapped. Compute if absent density function. What does compute if absent do? So it's a hash map. This dot multi-noise sampler goes new multi-noise sampler. So we do dot apply. Okay, what is the noise router? It's a record, fluid level, floodness noise, fluid level, spread noise, lava noise. Temperature. This is what we're looking for. We found it. Yes. We're one step closer. These are the noise types. These are all of the noise types. Want to play Bed Wars Ocarina of Time? I would rather eat my own shit Tom Pearl style. Don't ever say that shit to me again. Fucking loser. Ocarina of Time. You fucking loser. You seriously think I'm gonna play Ocarina of Time? I don't care about the codec. I don't care about the record. Apply. Noise density function, the density function visitor. Return new noise router. So we apply the visitor to all of these. This dot temperature. Where's that defined? Okay, so when you pass it through, it just, so this is like just, okay. So this dot temperature dot apply visitor. What is visitor? So apply takes in visitor. Okay, let's do any minute on a choice noise sampler. Noise router, get actual density function. So this is doing Aquafire stuff that we don't give a shit about. So we only care about the one in noise config. Fuck. So what is this doing? Let's take a look. It's in noise config. So this dot noise router equals that apply legacy noise definition legacy noise density function visitor. What is that? Implement density function, that density function generator. It does double Perlin noise sampler. If registry entry dot matches keys noise parameter keys dot temperature. Holy shit. Holy shit. These values that you're looking at right now this very line of code. This is responsible for every biome you've ever visited in the game. Well, 1/7 responsible. This line of code is 2, and so is this. This is 3 out of 7%. 3 out of 7, or nearly half, of the entire equation for the Nether. And we have found double Perlin noise sampler. And we don't care about all the class stuff it does. We don't need to implement that. All we really need to worry about is implementing only what we need. So we don't need to implement anything we don't need to implement, is what I'm saying. Minecraft has a bunch of stupid class bullshit. We're doing this procedurally with the goated language of humankind, Rust. So we don't need to worry about that. So we have figured out how Minecraft calculates temperature, offset, and vegetation. These are fixed values. So the first octave for the temperature is -7. The first amplitude is 1, and ... amplitude, something else, is 1. I can't see it. We'll look at the function in the future. Then we do the same for here. For offset, interestingly, noise config at this .random deriver .split noise parameter keys to offset to get value, new double Perlin noise sampler noise parameters. Okay, it's doing something, not exactly sure. We'll take a look at it. But we have found a piece of the puzzle. We're getting closer. This is 3/7 of the data. Now we need to figure out where all the rest of it is stored. And so what can we infer from this? Pre-biome stuff that Minecraft did, data was, or biomes were previously generated in the past in older versions using only temperature, offset, and vegetation. Those were the 3 parameters. It was a 3-dimensional noise. Now it is 7th dimensional, and so it's not in the legacy anymore. So there's some other piece of data that we need. The best part about this is we don't need to worry about all this visitor stuff. We're not copying the code. We are literally just copying what it's doing in the order that it's doing it. So this is going to make things a whole hell of a lot easier. Alright, let's take a look at where the rest of them are. Once I find where the rest of them are, I'm going to end the stream for now. But it's going to take me some time. So, we need to find out where continents, erosion, depths, and ridges are stored. Erosion, depth, ridges, temperature, offset, and vegetation. Okay, so temperature, vegetation, continents, erosion, depth, ridges. That's 1, 2, 3, 4, 5, 6. There was another one. None of those are offset. So, yeah. I'm going MG to Florida. We were planning on going to Florida, but we're too poor. We haven't gone on vacation like, I want to say 3 years, 4 years. Going to Florida July 1st. If only. create legacy. Okay, so theoretically we could just do noise parameter keys to find the rest. I am. Yeah, I know. Thank you for telling me. So these are all the parameters. It noise parameters keys. Okay, now what are the other ones that we care about? If we go to, we should actually check which ones the Nether uses. Otherwise we're just going to be searching for stuff that we don't give a shit about. Nether biome creator. Spawn, don't care. Generation. This is the steps he uses. We don't really care. We only care about the biome. Default biome features. Add default mushrooms. Add nether minables. Biome builder. Precipitation. Downfall. Alright, so biome. What does it take? There's like multi-noise util. Yeah. So here's what we care about. We have temperature. What is multi-noise util used for? We need humidity, continentalness, erosion, depth, and weirdness. We have temperature, offset, and vegetation. So vegetation doesn't seem to be inside the noise sampler. Maybe that's just an additional set of data for some other stuff. I don't know. So we need humidity, continentalness, erosion, depth, and weirdness. One, two, three, four, five, six, seven. Get humidity. Is humidity not here? It is not. So where is humidity defined? Okay, we'll do humidity second. We do have continentalness, so let's go ahead and find that. Density functions. Built-in noise parameters, potentially. Vegetation, temperature, vegetation, continentalness, and erosion. Right. Look at that. We have all the default values. So for continentalness, okay, we have some more data here. That's way too big. Okay, we need depth and weirdness. Let's do weirdness, because that'll probably be... That's not how to spell it. We got a few. Let's do you. Yeah. Not exactly what I meant. Weirdness. I'll tell you, it is also defined here. Right, yeah, I want to know where it, not necessarily where it used, where is it defined? Max height weirdness, max low weirdness. Okay, some fixed values, sure. Float, weirdness, noise. Okay, weirdness. Let's take a look at you. We have some weirdness stuff. This looks important. Can I type anything? Alright, I think I'm going to end it here because this is